In this lecture, we will be looking at the third kind of loop available in the C++ language, which is the for loop. The for statement has three parts. One is the initialization part, another one is the condition part, and the next one is the update part. And they are all separated by the semicolons. And after that, you can write a single statement ended with a semicolon, or you can write a compounded statement like multiple statements enclosed in curly brackets. So how it works is that in first step, it evaluates the initialization expression, and this part is only run once. And in the next step, if the value of the condition expression is false, the loop is terminated, and if it's true, then it executes whatever statements are enclosed in the for statement loop body. And then after running those statements, it evaluates the update expression, and then it repeats expression steps number 2 to 4 again and again, as long as the condition is true. So let's take a look at an example. Here it takes the input from the user and sums all the numbers from 0 to the integer entered by the user, and types its sum. So how it works is that we have declared a variable long sum, or we should have written long sum equals to 0, and then we have written that for integer I equals to 1, I is less than equals to n, and I plus plus. So at the first instant, this statement is going to run, and then it will check this condition. If this condition is true, then the whatever statements are enclosed in the loop body are going to run. Since it's a single statement, I do not need to include the curly brackets. Had it been like multiple statements, I could have I would have included those in curly brackets, and that statement would have runs as one loop body. And if this condition is true, then it will update the value the value of I is 1, then the value of I would be added to sum, and the value of sum would be updated. And after that, after running this whole loop body, this expression is going to run, and this is the first iteration of the loop. Then in the next iteration, or the next running of that loop, this condition is again going to be checked, and after running this after checking this condition, it will run this statement, and then after running the second iteration, this loop body would be this update step is going to run. So that's the second iteration, and the third iteration is going to check whether this thing is still true. It will run the whatever statements are there in the loop body, and then it will run this update expression, and it will keep on doing so as long as this condition remains true. And after updating this condition, and if the loop the compiler checks that this condition is now false, so it will exit the loop body. So first run this code here, and it says that enter a positive integer, and if I press for example 10, it says that the sum of first 10 integers is 5. Since we are adding a number again and again, so instead of writing those statements again and again, even though we don't know how many times we need to write the statement, so obviously using a loop is a better choice, because if the user has typed like 10, we need to add 10 numbers to from 0 to all the way to 10, or the first 10 integers, we need to add those numbers, and that means we need to run the code at least 10 times. If the user enters for example 15, then we need to run the code again and again for 15 times. So we could not use the repetitive statements, like I could have written like this is code for like 15 times again and again, but that would have been valid for only one scenario, in which the user enters 15, or then if I need to change the code to maybe 20 if the user enters 20. So loop is valid for this thing, or it's pretty much the only way to do some tasks repetitively. Now let's run this code in the debug mode, and I've added a for of sum and I to run this code. So let's debug this thing. Actually I have not included a breakpoint, so just add a breakpoint anywhere in the program, something like here. So let's run this code, and it says sum is 0 and I not found in current context. So this I is a local variable in for loop, so obviously we could use I multiple times, because this I only exists within this loop body, so it's right now not found. Sum is not even declared yet, but it says the value 0, but it doesn't even exist right now because we haven't declared it, we haven't initialized it. So it says enter a positive integer, and after running this line we should see the output here. So let's have a window right here. Okay, so let's run this line. It says enter a positive integer, and if we run this line and type for example, let's say we type 10 and press enter, the value of n is assigned to be 10. Okay, so that remains fixed because n is never changed. So this n, I mean, we don't need to add a watch for it because we are not changing the value of n. So it's now we have declared the value long sum 0, and after that the value of sum is this thing I. We are after running this line, I, the value of I is going to be initialized to 1. Right now it's just saying some garbage value, so don't worry too much about it. And after running this line, it the value of I is 1. It checks the condition 1 is less than 10, and after running this line, the value of I would be added to sum and the value of sum would be updated. So then it again here it runs this part of this code because it's the update value I plus plus would happen, and after that it will check whether chew, which is I plus plus, chew is less than equal to n. So let's run that. So chew is still less than equal to 10. It runs this line again, and it keeps on running as long as you need to watch these parts, as long as the value of I is less than or equal to 10. So after 10 iterations, the value of I is 10, and after running this line, the value of I would be 11, and 11 less than equal to 10 would be false. So it will exit the loop and the control will be transferred outside the loop at this point. So after running this line, I mean, it checks whether this condition is now false. So this condition is false, so it runs this part and says that the value of sum has been updated to 55 in the for loop body, and it's just see out that the sum of the first n integers or first 10 integers is 55, which we have seen in the normal running of this program. I could have let's remove that. I could have done the exact same thing with the while loop. I mean, in the while loop, this part of the code would have happened outside this because the I is initialized just once and that's it. But now it becomes not a local variable but kind of an outside variable, now visible at this point onwards, so all over the from this point onwards to here. But if we have declared this I inside this loop statement, then this I would have been a local variable, and this statement is, well, we should write this statement because this is essentially the while condition. Run this loop while this condition is true, and we could have also removed it from this point to this point, and now we could have enclose this thing into curly brackets. And if we enclose this thing into curly bracket, this thing is essentially a while loop saying but with a different name, obviously, saying that run this loop. I mean, this is the syntax of writing to semicolon. This is important for the for loop, but essentially I could have written a while loop here and remove this thing, and we could have, I mean, run this loop as long as this condition is true and keep on adding those numbers 1 2 3 4 5 6 7 8 9 10 to the variable sum, and after adding the number, update the value of I plus plus. And I mean, because this is the exit clause of this for loop. So that, I mean, this becomes really the while loop here, but the for loop gives us the facility that instead of writing these C statements in separately, we could written integer I equals to 1. This part only runs once, and this is the condition after the semicolon, and this is the update value. So after running this code, I mean, after running this code, it would have updated the value, and we do not need to write here. And this thing, obviously we do not need to write this thing, because, and now this variable becomes a local variable, so I can reuse a name I if I'm writing some another for loop, because this I only exists within this for loop body. So if we look at the scope of the variables which we have declared, I mean, this is essentially the same code, but I am summing the numbers from I to n by 2, and then from n by 2 is let's say if the user enters enter the positive number, user enters 10, so I'm adding the number from 1 to 5, and then I'm adding the numbers from 5 to less than maybe 10 or less than equal to 10. But the point is that this I mean, I'm not going to run this code, but the point is that this integer I, the scope of this I is just this loop body, because this is just a single statement. I do not need to write the curly brackets. If you want to write curly brackets and close that and close the single statement, you are most welcome to do that, but this for loop ends at the very first semicolon in this statement. This I exists only here in this for loop body, and this I exists only here in this for loop body. So I can reuse the name I because this is a local variable. Had I declared the variable I at this point, and I mean if at this point, then I could not have reused this thing because that I belongs to the loop body outside the sorry that I belongs to would have belonged to the main function code block, not in the loop body. So here if I'm declaring those, yes, I could have used that, but I mean that could have been kind of confusing here, but here it's no longer confusing because this I is essentially a local variable. If I've declared an I here and then if I declare another I here, that would have hidden the I which is visible outside this. I mean because on this scope of this thing only this I exists, any other I is hidden which is outside this scope. So coming to the factorial example, factorial numbers which we have done in the previous lecture, recorded lecture of with the while loop. I mean this is essentially the same code, but instead of writing this, I mean factorial numbers are 1 factorial, sorry 0 factorial and 1 factorial are 1 1, so we have written 1 and 1 here. And here what we have done here is that enter a positive number and assign it to bound, and these factorial numbers are, and after that we have started from id2, and this factorial result is less than or equal to bound. We run this code as long as this condition is true, and after running this whole loop body once, this statement is going to run, and then it will check this condition whether this condition is true or not, and then it will, if this condition is still true, it will run this part, and after running this whole code, it will update this part or it will run this way, and then it will check whether this condition is true. So it will keep on running this code again and again, and after each running of this code, I mean it will run this code again and again if this condition is still true, and after each iteration or after each running through or going through this code is going to update this value or run this part after each iteration, and then it will again check the condition whether this condition is true or not, and it will keep on doing so as long as this condition remains true. If this condition becomes false, it will exit the loop. I mean other than that, it's essentially the same as we have done before with the while loop, and this part is only run once for the whole loop execution, and after that it just runs the, I mean it just says the factorial numbers are, which we have seen the result already. And this is simply another example of a descending for loop. I mean you could have, instead of using the I from 0 to 10 maybe or 0 to 9, we could have said that, I mean we could have run in reverse. That's also not a problem. I mean it starts with I equals to 10, I is more than, and it keeps on running as long as I is greater than 0, and after each iteration it's going to subtract the value or decrement the value of I. So for integer I equals to 10, so if you run this code, it says I mean essentially a descending numbers list 10 9 8 7 all the way to 1, because in each iteration, I mean I could have also given a step of I minus equals to 2. So if you want to take steps more than more than 1, you could have written I equals to I minus equals to 2, or I equals to I minus 2, or I minus equals to 2, or maybe 3, or I plus equals to 3, so that, I mean you can take more bigger steps, and it's not necessary you take the single increment or decrement steps. In this code, we are using a Sentinel. Sentinel is an input variable that controls the loop. Obviously we are taking the input from the user, and that input is assigned to some variable, and that variable is being used to control the loop. So that variable, that input variable, is known as a Sentinel, just a computer programming term. I mean not really asked anywhere, but this thing, we are just taking an input from the user, an integer, and I mean we're declaring two variables, and we are saying that enter positive integers and 0 to quit. So what we are doing here is that we are trying to find the maximum of a sequence using for loop. So whatever the user is typing, the numbers, positive integers, except 0, we are going to update the value of the maximum. So first let's run this code and see what's going on here. So let's run this code. It says enter, let's say 10 or 0. I mean let's run this code here. Okay, So enter positive numbers. If I press 10 and then I press 11, then I press 7, then I press like 8 and 5, and for example 4 and 77 and 44, it just keeps on taking the input. If I press 0, this loop exits, or this program exits, and says that the maximum number of the sequence which we have typed is 77. So just an example how it works. So we're sticking in the numbers, and as long as the numbers are greater than 0, it's running the code. So this part is not necessary, we are not updating anything. This part only runs once. So we take the input and we assume, because the user has typed just one input, and we assume that the maximum value is whatever the user has typed. If and this condition is true, if the n equals is greater than 0, then what we do is that we check whether the number, at the first iteration this thing is okay. So if we check whether n is greater than max equals to n, this at the first iteration this part is not going to run because max is equal to n, obviously. So this part is obviously not going to run because this condition is false at the first running of this code. Let's assume that I have not typed n is 0. I have not typed the first input as 0, because that would have just exited the whole program. It only runs when the value of n typed in by the user is greater than 0, not negative numbers, and 0 is used for exiting the whole program. So if this condition is true, then this works. So obviously it doesn't work. Then we take another input. Let's say the user has typed, for example, the first number was 3 and the next number is 4. So this thing is checked. 4 is greater than 0. Okay, that is okay, true. So this 4, if it's greater than max, if max contained the previous value of n at the first instance, and let's say the previous value or the first value typed in by the user was 3. So 4 is greater than 3, so the value of max is updated. So if this thing is updated, then we take another input. Let's say the user types in the value, for example, 1, and keep in mind the value of max is now 4. So it will the input entered by the user is 1. So 1 is greater than 0. This part is only run once, so you can just forget it right now. So 1 is greater than 0, that is true. So 1 greater than 4, that is not true. The maximum value is still 4, so that remains there. We take another input, and let's say that input is now 10. So 10 greater than 0, that is okay, and this 10 is greater than 4. The value of max is updated, and it will just keep on running as long as, let's say, the next number entered by the user is 0. So it checks 0 greater than 0. This condition becomes false. So it says out maximum equals to whatever the last number entered, whatever the maximum number was, which was 10. We could have more than one control variables. We could have saying that, we could have run two statements here, integer m equals to 95, n equals to 11, and we could take the remainder, that m, if this thing, and we could have this condition obviously has to be like one expression which could return either true or false. If I just write, instead of this place, if I just write 1, so that will become essentially an infinite loop if there is no exit condition. Here we are using two control variables. We could use that because these part are going to run after each iteration of the loop. This is actually possible to do so if you want to use more than two or more than one control variables. In this program, we are taking the numbers input from the user and adding those numbers and taking their average. The user can type any number of any quantity of numbers. So we have declared three variables, n, count, and sum, and we have initialized the value of count and sum to 0. Let's run this code and see what we get. It says enter positive integers and 0 to quit. So if I type 0, the program just quits and says the average of 0 positive number is not a number because that is dividing 0 by obviously 0. We haven't entered any number. So let's run this code again, and it says that enter positive numbers. If I write for example 12 and for example 15 or 18 and 4 and 3, 2, whatever, and then if I type 0, it says the average of those 6 positive numbers. So we are going to generate a list obviously with some kind of a serial number, and 6 positive numbers is nice. It has added all these numbers and divided by 6 to get this get the average of 9. So how it works is that we just see out in a statement, and then this is a forever loop. This will just run forever. So obviously we need some kind of a break clause here. So if if we did not do that, this loop will run forever. So we probably, this loop will never end. This is really similar if I write while, either in simple while loop or a do while loop. If I just write 1 or if I just write true. So this thing, I mean, is either while or into while, so that loop would have run forever. So this thing is similar to that. I could have also written here as, I mean, I could have written true here, or I could have just written 1 here, because the expression given here evaluates to either logical 1 or 0. Or the short form is just don't write anything in between these two semicolons, so that would be taken as true by default. This C out, I mean, with a backslash T, and we are saying that count plus 1. Count is 0, so if the user has typed the first number, the one number 1 and colon, and the first number would be taken by the number user, and that would be displayed. I mean, that would be, because we are seeing that number, that would be, you know, we are typing that number, that would have been displayed on the screen anyway. So if the user typed in the number which is less than 0, we are going to break the loop. We are not going to rest of the loop body, we are not going to do any more stuff, we are just going to break the loop, and the control will be transferred here. If the value of n with the entered by the user is more than 0, then we say, when we increment the value of count, the value of count would have been now 2, and then we update the value of sum, which was 0, and we update the value whatever the user has entered. We updated the sum with that number, we added that value and updated the value of sum. Then we can again, here the condition is still true, obviously we haven't done, I mean, this is true forever, and we say that backslash T, and we say that with a single tab, count plus 1, that would have been 2 here. I mean, right, sorry, here in the first iteration the count value would have been 1. Now we say the next number 1 plus 1 would have been 2, and then we say cn and the next value 2 colon or whatever that number. If that number is still more than 0, we do not break, and we increment the value of count would have been now 2. So we update the value of n to sum, and then we go here again, and that would have displayed 3. And then we have to type in the third value, and we'll just keep on going forever as long as the values entered by the user are more than 0. And after running, I mean, if the user enters 0, so it will take the input and will check this thing, and it will break the loop. The control is transferred here, and it says that the average of those numbers or those positive numbers is sum, because we need to typecast it here. So sum would have been the last updated value of all the summation of this number divided by the count, which was the essentially a counter which was tracking how many inputs the user has typed. So before the running of the loop, that count value was 0, and after each successful entry by the user, we were updating the value of count, and we are dividing it by count. So this thing is going to be a fractional number, and it's a simple example of using a forever loop. We could also use the continue and break statements in a for loop. This is essentially a for loop, and it says that if this remainder, if you have typed in the number which is divisible by 3, so the remainder would have been 0. So we would have broken the loop, and the control is transferred here. I've already explained how break works. This continue statement, what it does is that if this condition is true and we say continue, that means that skip or ignore whatever is written in the rest of the loop body and go to the next iteration of the loop. So let me repeat that. If this condition becomes true, what we are saying to this program is that in that iteration, ignore whatever is written here and go to the next iteration. That's what we mean by that. So continue means essentially is stopping that iteration right there and then and going to the next iteration, and not executing any more steps in that iteration only after that continue statement. So continue means skip rest of the loop and continue with the next iteration or the next repetition of this program. So if I run this program, so let's run this program. It says enter integer, enter some number. So if I type, for example, 7, so 7 percentage 2, 7 remainder 2 is not equal to 0, so this thing is not going to work, and 7 percentage 3 is also not equal to 0, so it will display bottom of the loop and in this part here, because I mean these two conditions are not true, so in both of these statements obviously did not run. And it says bottom of the loop, and then it came back here. This thing is a forever loop because this thing is always true, and it says enter an integer. So if I type an integer, for example 8 is divisible by 2, so it will continue means it will not display this bottom of the loop here, it will go to the next iteration. So let's type here 8, and it says enter integer, so it did not display this because 8% 8 remainder 2 is 0. That is true. So this continue means ignore these two things in the next in this iteration and go to the next iteration. So it again says enter integer. So if I type, for example 10, it says enter integer. If I type 12, it says enter integer. If I type 80, it says enter integer, because all these numbers are divisible by 2. So if I type a number, for example 9 is divisible by 3, it says it now what will happen, it will break the loop altogether and the control is transferred outside of loop. So if you want to, if there is some condition in which you want to go to the next iteration without running the rest of the loop body, you use the continue statement. If you want to exit the loop altogether, you can use the break statement. If you want to terminate the program, the whole program, whatever is written, I mean not exit the loop then go to outside of the loop, if you want to terminate the whole program, you can use the exit 0 function, exit with a 0 in the round brackets. In this program, we are using something known as nesting loops or nested for loops, because one loop is inside another loop. So that means that if this loop runs from 1 to 12, so this loop is going to run from 1 to 12. So for each iteration of this loop, this thing is going to run 12 times. So that means that this thing is going to run 12 times after running this code, whatever is here in this line. This code, after running this thing for 12 times, this will run next, and that means that the whole program, I mean this whole statement would run 12 into 12 144 times. So first run this code and see what we get. So it's actually printing the tables of from 1 to 12 all the way to 12, obviously. So this is a table of 1, this is a table of 2, this is a table of 3, and all the way to 12, and the tables are generated for each number up to 12. So 2 into 12 is 24, and 10 into 12 is obviously 120, and 12 into 12 is 144. So we are doing a repetitive task, and that repetitive task is also done repetitively. So we are actually generating a table from 1 to 12, and that passed that task is also done repetitively for each number. So obviously we are going to use something known as a nested loop. So this nested loop, I mean it is just single statement, so we do not need to use the curly brackets, but just to emphasize what this curly brackets actually mean is that this loop is going to run, I mean this part is going to run for each iteration, this part is going to run for 12 times. So if I just go to debug and let's add a watch somewhere, let's say if I add a watch or add a breakpoint, sorry, not watch. So I mean the value, I mean this is self-explanatory what the values of y and 12 are. They are just multiplying the values of x and y. For the first iteration, the value of x is 1 is less than 12, so we enter here. So this part is going to run as long as this condition is true. So y is 1 and it's actually less than 12, so this part is, I mean x into y is going to run. So value of value of x was 1 into 12 1 into 1, because in the first iteration this thing is 1 and this thing is 1 into 1 is 1, and in the next iteration y is incremented and the value of y is 2 is less than equal to 12. So this x 1 into 2 is 2, and then in the third iteration of this loop 1 into value of y would have been 3 and this thing will keep on executing here. So looking in the debug mode, I've changed this code to \n because this handle was causing some problems in the debug mode. I'm not so sure why. So let's run this code and debug this thing, and we are going to see the output here. Let me set this Windows. So if I go to this next line, the value of x, I mean this value, we need to watch these values. So y is still not found, and it says after running this thing, y is just garbage value. After running this part, it says see out value of y and x are both 1, so it will just see out 1, and it will just keep on repeating this thing as long as this condition is true. So that will remain in an inside loop as long as the condition is true. The y value of 9 is 10, it's 11, and now it's 12, and then after that y plus plus would have been 13, and that would have exited the loop, and this thing, this see out would have been run, and the cursor would go to the next line, and the value of value of x is 1. So now the value of x was 1. It will update the value to true value, and then it will again enter the inside loop, and it just keeps on running this code again and again as long as the value of y is less than equal to 12. As soon as the value of y is 13, I mean after running this part, it will just value of y is 13, and that will exit the loop at this point, even though that is actually showing 12, but the why it exited was 13 is less than equal to 12. That condition would have been false. So actually this thing is outside this loop. I mean, it should have updated the value to 13, but here, since it's outside this loop body, so this y is no longer visible at this point. So it will go to the next line, and then it will enter the third iteration of the outside loop, and it will keep on exiting, keep on running this code again and again as long as the inside condition is true. So it's actually much more similar to I mean, if I write something like if you have seen, I mean, if I have some kind of a counter going from 0 0 to 0 1, 0 1 to 0 2 to 0 3 to 0 4 to 0 5, and to 0 6, 0 7, 0 8, 0 9. What would happen if the units number are now finished? So the next iteration would be 1 0. So this outside outside number runs 10 times, and then it's updated. This outside number is same for the 10 iterations of the inside number, and then it updates to the next value. So I mean, it's saying that, I mean, if you if you can look at it, the inside number from 00 to 99, the inside number goes from runs like 100 times, and the outside number runs only 10. So if we have two nested loops, so the amount of iterations would be the product of the running, or the quantity of the running of both loops. So if the outside loop is running here is 12, and the inside loop is also running for 12 times, so the total number of iteration would have been 144. So inside, I mean, if you are doing some task repetitively, and that repetition is also being repeated, so for that you need to use something known as nested loop. You can use 3 nested loops or maybe 4 nested loops, but watch out, I mean, those programs can become really long. So we need to stop execution, and very quickly we could have a break in nested loop if we want to. So if this condition is true, we are just saying break. So that means that the this loop would have been broken, and the control is transferred to the outside loop. I mean, this part here is I mean, for this for loop either ends here or here, because we are using if else. So if you want to make much more clear, so we can just write bracket. I mean, it's not really needed, because this for statement only contains either this statement or this statement. So if this condition is true, for loop enters here. If this condition is true, for loop this for loop enters here. If you are using a break thing, so that iteration of that for loop would have ended, and the control is immediately transferred to outside the loop body. I mean, if you are using a debug mode, I would suggest you use \n because for some reason this end is causing problems in the debug mode, and this break would have broken the loop, and the control is transferred outside here, and the outside loop would have still run. So it would have again entered the loop, and if this condition is true, that the inside loop would have been broken, but not the outside one. So the break statement only works in the loop in which it is written. It does not break the outside loop, it only breaks the loop in which the break statement is written.